Hello everyone, my name is Edgar Pavão, lead developer of the project Migration for Delphi. A migration is an upgrade, so whenever you need to update, you can use a migration for do this. A migration is not more than a class. The easiest way to develop it is inherit directly from the T-migration class, but it's not the only way. You can create your class directly from the iMigration interface. However, I recommend that you inherit from the T-migration class for easy. The structure of a migration class is very simple. It has basically 5 methods. The setup method is responsible for defining information on migrations, such as example, the versions, its sequential number, and its creation date. This method is executed before the migrations are executed. Then any staging code for the executions of the migrations can be added there. The up method runs every time the migrations will be executed. It's the method that will update, so your application update code should be within this method. The down method runs every time a rollback is running. It's the method that downgrades. Thus, the downgrade code for updates should be within these methods. The up execute method determines whether the update will run. Depending on the scenario, an update may or may not be performed. Maybe in determined customer or determined environment, a specific update does not should be performed. Thus, if this method returns false, this update does not will be performed. Similarly, the down will execute method defines whether the rollback will run for this migration. Another important feature of migration is that it needs to be registered for the mechanism to understand that it exists. This should be done preferably at the time of the unit initialization using the procedure register migration. Some people may argue that this will lead to a process and use of unnecessary memory in the normal use of the system when an update not used. This is not necessarily true, because a Git project will deprive the system of this inconvenience. Ideally, the update engine should be in separate module, such as a DLL, for example, running only when an update is required. In addition, migrations were designed with memory in mind. So note that it's the classes that are registered, not the objects instantiated. When the migration is used, the class is instantiated, used, and then released from memory. This ensures better memory management, avoiding wastefulness for environments with few resources. Knowing this, we can already create our migrations and verify its operation. So, the method setup will just inform initial version here, for example, version 1, the first sequence 1, and the date time of creation of the migration. Okay, already done. In the method up, here we will simulate execution of update. Okay, so we will just show a message here. And for method down, we'll do the same thing. Okay, show message. Okay, so this is enough to understand the functionalities of the migrations. Okay, so here we just go to the main form. I need to use to declare the migration unit and the project unit M4D. Okay, to execute this migration, we just call the migration facade and call for execute. Okay, to roll back the same way, we use migrate facade and call for rollback. Okay. The important here is understand that a migration is registered using the procedure register migration. Okay. So we can execute that. When I execute, I get the update migration 1 message, and when I roll back, I get the downgrade migration 1 message. Okay. Okay. So we will create before I will show the functionalities of the methods up will execute and down will execute. So for example, up will execute here, I'm returning true. Okay, if I return false, these migrations will not be executed because the migration return false for this environment, okay, or for this execution. So if the method up will execute return false, the up will not execute, and if the method down will execute return false, the downgrade will not be executed. Okay, so I will go back to true, and I will create a new migration here. Okay, I will save as second migration. Okay, here I have my first migration, and here I will have my second migration. Okay. Okay. Here the second migration was registered. Okay, will be registered here. So I will put here 1.1.01, okay, and sequence 2, okay, in the setup method, and up method I will show a message again to simulate the execution of update. Okay, so we'll be executing the second update. Okay, and here in the down method I will put executing the second downgrade. Okay, I just need to declare here the dialogues. So this is enough to work, and I can execute again. When I call for execute, the first migration is executed, and after the second migration is executed. Okay, when I call rollback, the second downgrade is executed before, because the second is the last one, so this is the inverse order. Okay, so the second will be executed first after the downgrade of the first migration. Okay, if I go to the first migration and change up will execute for false to false, when I execute it, you can see the first migration will not be executed. Okay, so just the second. So the system just execute the second migration because I code to not execute the first one. Thanks, this is all. I hope you enjoy it. Bye bye.